Okay, so we're going to start reviewing for our second test, which is going to be Friday on October 11th. For question number 1, simplify the following expression. So this is our exponent stuff that we did on the very first day of school. So for this question, the numerator, 2x, the part of the numerator, 2x squared, y to the negative third is being raised to the fourth power. So that 3 is going to be multiplied by after the fact. So we have 3 times 2 to the fourth. You're not doing 2 times 4 because it's a coefficient. You do 2 to the fourth normal. So 2 to the fourth is 16. And then we have power to power, you multiply. So x squared to the fourth is x to the 8th. And then y to the negative 12th. Divided by, this is now 8x to the 10th, y to the negative 15th. So I'm going to actually multiply 3 times 16 to give me 48 in a second. And I also want to switch the y's around because they both have negative exponents. So now I have 48 x to the 8th, y to the positive 15th, divided by 8, x to the 10th, y to the positive 12th. So now I just have to clean this up. 48 divided by 8 is 6 over 1, or just 6. X to the 8th divided by x to the 10th. You're going to subtract and then put the answer in whichever exponent is higher. So 10 minus 8 is 2. And then that's going to go to the bottom, x squared, because 10 is bigger than 8. And then for y, it's 15 minus 12 is 3. And that's going to go in the numerator. So my final answer is 6y to the third divided by x squared. For number 2, find the inverse of the function. So I'm going to switch the x and the y. So this is now x equals 3 over 4y plus 9. Now I'm going to solve for y, so I'm going to subtract the 9 over, so x minus 9 equals 3 over 4y. And instead of dividing by 3 over 4, to get rid of it, I'm going to multiply by 4 over 3. Don't divide by a fraction, multiply the reciprocal instead. So now I have 4 over 3x. If I multiply negative 9 times 4 over 3, that gives me negative 36 over 3. Or just negative 12 equals y. Now, the question doesn't say to find this notation, so technically this could be an okay answer, okay? Or you could write it this way. If it says to find this, then your answer has to say the correct notation equals, and then it would be 4 over 3x minus 12. Numbers 3 through 6 wants you to factor. Not to solve, just to factor, okay? So for number 3, I take out a GCF of 2x, and I am left with x to the third plus 8. Now x to the third plus 8, I can keep factoring using SOAP. X to the third is a perfect cube, and 8 is a perfect cube. The sign in the middle does not matter for SOAP. So I have 2x, that was my GCF. I have a small set of parentheses and a large set of parentheses. To figure out what goes in the smaller set, I take the cube root of each part. So the cube root of x to the third is x. The cube root of 8 is 2. And then, so this is your a. This is a. This is b. So now we have a squared, ab, and b squared. So if a is x, then a squared is x squared. A times b is 2x, and b squared is 4. You don't need to have this on the bottom. So if you don't have this A, B stuff, really, that's just to help you guys. And then lastly, you still have to do the signs. So you're going to do SOAP on the signs. This was a plus, so we have same, opposite, always positive. And that's it for number 3. If you take out a GCF to start, you are never going to be able to factor that trinomial further. I mean, you could try to, right? You would do 1 times 4 is 4. But then no 2 numbers multiply to be 4 but add to be a negative 2. So it's completely factored now. For number 4, again, whenever I give this to you, do not combine like terms because it's set up for you in a specific way. So I'm going to try and I always try to split it down the middle first and see if that works. So on the left side, my GCF is x squared, and I'm left with x squared minus 2x minus 3. On the right side, my GCF is negative 16, and I'm left with x squared minus 2x minus 3. So this is now x squared minus 16 and x squared minus 2x minus 3. Now remember, we want to completely factor according to my directions. So x squared minus 16 I can factor further using the difference of two squares. The square root of x squared is x. The square root of 16 is 4. And I have 1 plus and 1 minus. Now x squared minus 2x minus 3 is a little bit more work because that is master product. So I'm going to do this over here. X squared minus 2x minus 3. So I need two numbers that multiply to be negative 3 but add to be a negative 2. It's going to be negative 3x and a positive 1x. On the left side I take out x. I'm left with x minus 3. On the right side I take out a positive 1 and I'm left with x minus 3. My parentheses match, so this is now x minus 3 times x plus 1. So I just have to write that back over here. X minus 3 times x plus 1. And now that is completely factored. Again, anything that you see in here, in your final sets of parentheses, there's nothing else that you can do. You cannot do the difference of two squares on x minus 4 because x is not a perfect square. If it were x squared minus 4, you could. Number 5, this is that weird factoring, right? So instead of multiplying everything out and wasting all of that time, what you can do is you can say, let u be x plus 5. That way now you're looking at 3u squared plus 2u minus 8, which would just be master product. So two numbers that multiply to be negative 24 but add to be a positive 2. That's going to be a positive 6u and negative 4u. I split it down the middle. On the left side I take out 3u and I'm left with u plus 2. On the right side my GCF is negative 4 and I have u plus 2 left over. So then this is 3u minus 4 times u plus 2. The problem with leaving this as my answer is that the question was in x's. So I need to then take the u's that I have and replace them with x plus 5 because that's what u stands for in your let statement. So you need to do 3 times x plus 5 minus 4 and then x plus 5 plus 2. So one set of parentheses that ends up being distribute the 3. 3x plus 15 minus 4 is 3x plus 11. And then the other one, x plus 5 plus 2, is x plus 7 now. All right, so you could have gotten this answer if you multiplied everything out. It's just you're going to spend a lot more time doing this question than what I just did. Okay? Pause it now if you need to copy that. I'm going to erase it. That way we have room for number 6. And number 6, so x to the 4th plus 2x squared minus 35. So you have two options for this. Because it is just doubled, you could do just master product and then make the terms in the middle x squared instead. Or you can say let u equal x squared if you wanted to. So if I do that, let u equal x squared. That way now it's u squared plus 2u minus 35. So I need two numbers that multiply to be negative 35 but add to be a positive 2. That's going to be positive 7u and negative 5u minus 35. On the left side, take out a u, I'm left with u plus 7. On the right, negative 5, left with u plus 7. So this is now u plus 7 times u minus 5. But again, I need my answer to be in x's. So I'm just going to take out u and replace it with x squared. So my final answer to number 6 is x squared plus 7 times x squared minus 5. Which you could have gotten just by doing master product and replacing, for example, instead of writing 7x and negative 5x, you would just write 7x squared and negative 5x squared. Okay? Numbers 7 through 9 want you to simplify the imaginary numbers. So for number 7, before you type this into your calculator, you have to clean up each of the individual parts. So you have to type each piece into iPart in your calculator. You can only type in monomials into iPart. To get to iPart, you press math, you go over to number, and it's option number 3. So when I type in 5i raised to the 93rd power, it gives me 5i. When I type in negative 12i to the 46th, it gives me positive 12. And then when I type in I raised to the 128th, that gives me 1. So now I just combine like terms. 12 plus 1 is 13 plus 5i. You always want to put your answer in a plus bi form, which is set in your directions. A plus bi form, meaning that the I comes at the end. For number 8, you can just type into your calculator because there are no high exponents in there, like in number 7, and then there's no variables in there, like in number 9. So for number 8, though, I want to show you how to do this by hand, and then just know that you can type it into your calculator to double check it. So I'm going to do 7 times 8. I'm going to have to double distribute. Gives me 28 minus 7i plus 12i minus 3i squared. Then we have minus 10, Right, if I distribute the negative 5. Negative 5 times 2, negative 10. Negative 5 times I, negative 5i. So now I'm going to clean up this a little bit and combine like terms. So 28 minus 10 is 18. Negative 7i plus 12i is 5i. Minus 5i cancels out. These all cancel out. And then you have minus 3i squared. Negative 3i squared, right? I squared is negative 1. So negative 3, it's very important that you know that I squared is equal to negative 1. Negative 3i squared, so negative 3 times negative 1 turns into positive 3. And then I can combine those. So my final answer to number 8 is 21. All right, so your calculator will give you just 21 for number 8. And then number 9. Number 9, we have this tricky part, the squared part. So I'm going to rewrite this as 3x plus 5i minus 2x plus I times 2x plus I. So this is 3x minus 5i minus, I'm going to multiply this out and keep it in parentheses. That way I can distribute the negative after. So 2x times 2x is 4x squared plus 2xi plus 2xi plus I squared. So now if I combine like terms, this is 3x. Well, if I distribute the negative before I combine like terms, rather. So now this is minus 4x squared minus 2xi minus 2xi minus I squared. So 3x minus 5i minus 4x squared. This is now minus 4xi. And then negative I squared turns into positive 1, right? It was negative 1i squared. Now it's positive 1. And there's actually no terms for me to combine for number 9. So my final answer is actually kind of messy, but I'm going to put negative 4x squared plus 3x and then plus 1, and I'll put my imaginary numbers at the end. So minus 4xi minus 5i. Okay, but that's a lot going on for number 9. And then this last section, numbers 10 through 16, just want you to solve each equation in simplest form. If it tells you what method to use, I want you to use that method. And then if your solutions are imaginary, of course they should be in a plus bi form. So for number 10, it wants me to factor this. So I'm going to subtract everything over, right? Because whenever I'm factoring, I need it to set equal to 0. And now I need two numbers that multiply to be 6 times negative 15 is negative 90. So two numbers that multiply to be negative 90 adds to be negative 1 are going to be negative 10 and a positive 9. So this is now 6x squared minus 10x plus 9x minus 15 equals 0. I split it down the middle. Over here, my GCF is 2x. I'm left with 3x minus 5. On the other side, I can take out a positive 3, and I'm left with 3x minus 5. So this is 3x minus 5 times 2x plus 3 equals 0. So my final step is to make this t-chart. 3x minus 5 equals 0. Add the 5 divided by 3, so x equals 5 divided by 3. The other one, 2x plus 3 equals 0. Subtract the 3, divide by 2. X equals negative 3 over 2. Those are my two answers. Only have two answers because this is x squared. Number 11 wants you to solve by completing the square. So your first step for completing the square is to subtract the constant to the other side. So now I have 2x squared minus 8x equals negative 106. Second step, make a equal to 1. Right now it's a 2, so I have to divide everything by 2. That way now I have 1x squared minus 4x equals negative 53. So now it's in the form that I want, so I'm going to do half it, square it, and then add it back. So half it, so half of negative 4 is negative 2. Negative 2 squared is a positive 4. And then add it back. Negative 53 plus 4 gives me a negative 49. So now when I go to take the square root, I have x minus 2 equals plus and minus the square root of negative 49. So the square root of 49 is 7. The square root of negative 49 is 7i. So we have imaginary answers for number 11. So the last thing I would do is just add over the 2. And that 2 is going to go out front. So 2 plus and minus 7i. Those are my two answers for number 11. 2 plus 7i, 2 minus 7i. They are what's called conjugates. For number 12, it tells you to use the quadratic formula. So I need to put it into standard form. Ax squared plus bx plus c equals 0. So right now I have 5x squared plus 5 equals 2x. I'm going to subtract the 2x to the other side, and that's going to go in the middle. So 5x squared minus 2x plus 5 equals 0. So a is 5, b is negative 2, and c is 5. So when I plug this into quadratic formula that's on my reference sheet, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I have not picked up my calculator yet. X equals 2 over 10 plus or minus the square root of something over 10. Now you can pick up your calculator. You will do negative 2 squared minus 4 times 5, which will give you negative 96. Okay, so I'm going to keep simplifying and come up here now. So the square root of negative 96, the largest perfect square that goes into it is 16 times 6. So I'm going to put the negative with the 16. I'm left with the square root of 6. So now I'm going to keep the fraction to start. X equals 2 over 10 plus or minus. The square root of negative 16 is 4i square root of 6 divided by 10. And then I just clean up the fractions. So 2 over 10 is 1 over 5 plus and minus. 4 over 10 is 2 over 5. And the I square root of 6 just gets dragged. And that's my answer to number 12. For number 13, this is not a quadratic. So it's not a quadratic, so that means there's only one way you know how to algebraically solve this, and that's by using factoring. So I split this down the middle. On the left side, I take out x squared, and I'm left with x minus 5. On the right, my GCF is a positive 16, and I'm left with x minus 5. So then I have x minus 5 comes out. I'm left with x squared minus, plus 16. There is nothing else I can do to factor this right now. X squared plus 16, you cannot factor using the normal difference of two squares. So I'm going to set each of my factors equal to 0 and solve. So x minus 5 equals 0. That's my easy one. That gives me x equals 5. That's my first answer. I need 3 answers. On the right side, x squared plus 16 equals 0. So x squared is equal to negative 16. When I take the square root, I get plus and minus, and then the square root of 16 is 4. The square root of negative 16 is 4i. So my 3 answers are 5, 4i, and negative 4i. Okay, number 14. This is my fraction. I'm going to cross multiply to get rid of it. So 9x squared times 1 is 9x squared. And then 4 times 4 is 16. 4 times negative x is negative 4x. This is a quadratic. Because my a value is so large, I'm going to not do completing the square. So this is 9x squared plus 4x minus 16 equals 0. You can do completing the square on this. Okay, I'm just going to go ahead and do some quadratic formula. So for the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4 times a times c is negative 16, all divided by 2 times a. Have not picked up my calculator yet, still not going to. Negative 4 over 18, plus or minus the square root of something over 18. Now you can pick it up and do 4 squared minus 4 times 9 times negative 16. That should give you 592, big number. And I have to simplify that. So I go into my calculator and I see what's the largest perfect square that goes into 592. It's actually going to be 16 times 37, where 16 is your perfect square. So here, because it's positive 592, my answers are not imaginary. So now I have, let me go back to my red. Now I have x equals negative 4 over 18 plus or minus 4 square root 37 over 18. And then finally, I'm just going to clean up my fractions. 4 over 18 gives me 2 over 9. So I have negative 2 over 9 plus or minus 2 square root of 37 over 9. Last two. For number 15, x to the third plus 125 equals 0. Again, this is an x to the third, so I should have 3 answers. I also can only factor to solve if I am asked to solve algebraically. The way that I would factor x to the third plus 125 is using SOAP, that perfect cube stuff. So for number 15, I take the cube root of each one. The cube root of x to the third is x. The cube root of 125 is 5. So now I have x squared, 5x, and 25. And then I do SOAP for the sign. So same, opposite, always positive. I can't factor any further, so I'm going to set each thing equal to 0. So x plus 5 equals 0. That one's easy. That gives me x equals negative 5. For this side, though, x squared minus 5x plus 25 equals 0. That is not factorable, but it's a quadratic that you have to solve. You can either do completing the square or quadratic formula. So I just did some quadratic formula, so I'm going to do completing the square. X squared minus 5x equals negative 25. My a value already is 1, so I don't have to do any division. So I'm going to half it. So half of negative 5 is negative 5 over 2. Keep it in fractions. When I square it, I get 25 over 4. And then add it back. Negative 25 plus 25 over 4 gives me negative 75 over 4. And then when I go to take the square root, x minus 5 over 2 equals plus and minus. So remember, this is the square root of negative 75 divided by the square root of 4. The square root of 4 is 2. 75 is 25, well, negative 25, times 3. So it's going to be 5i square root of 3 over 2. So x minus 5 over 2 equals plus or minus 5i square root of 3 over 2. So my final answer, you have to add the 5 over 2 over, plus or minus 5i square root of 3 over 2. So those are my three answers, x equals negative 5, and then these two right here. And then last one, number 16. So number 16 is a quadratic. Actually, this is a factorable quadratic. 8 times negative 3 is negative 24. Two numbers that multiply to be negative 24 but add to be a positive 2 are going to be negative 4 and positive 6. So 8x squared minus 4x plus 6x minus 3 equals 0. So I take out a GCF of 4x. I'm left with 2x minus 1. On the other side, my GCF is 3, and I'm left with 2x minus 1. So this is 2x minus 1 times 4x plus 3 equals 0. Set each of my factors equal to 0 and solve. On this one, I get x equals positive 1 over 2. The other one, x equals negative 3 over 4. So even if you chose to do a different method for number 16, you should still get the same answers that I did. Okay, and that's your review sheet for this test. If you have any questions, I hope to see you at Extra Help on Thursday after school. Have a good day.